You can film the
Okay.
analysis on the board.
Are you okay?
Yeah, continue.
Illustration 2. Adamu Grocery Store Nigeria Limited deals in a perishable commodity for which the daily supply and demand are subject to a random variation and not forecastable. The records maintained over the previous 350 days reveal the following patterns: kilograms available for purchase, correct as we have it here. The number of days, correct as we have it in the
Okay.
question.
Okay. No, we have not finished the question.
The potential demand over the same period revealed no seasonal variations and had the following patterns. The following pattern: kilograms demanded is correct as we have it here. Number of days, correct as we have it here. 1 kilogram of the commodity costs 24 naira and sell for 36 naira. If it is unsold at the end of the day, its scrap value is nil. If there is unsatisfied demand on any day, it means a loss of goodwill of 6 naira per kilogram.
At the end of the figure, you start.
You are required to prepare simulation for the first 7 days, giving a series of random number table as follows: 57, 34, 23, 70, 97, 51, 48, 36, 81, 32, 09, 31, 64, 49, and 23.
Okay. That's the end of the question. If we look at this question now, I think when I'm talking, you can concentrate on me. Now, if you look at the question, now you can discover that you were only given kilograms of purchase, number of days, kilogram demanded, number of days, nothing like probability. But the question still requires probability. There is no way you want some simulation with it that you want to determine the probability. That's number one. Then number two, we were given some parameters. The first one is that 1 kilogram of the commodity costs 24 naira. That 24 naira is the purchase price, and the selling price was put at 36 naira. Then he said if it is unsold, that the scrap value is nil. The scrap value will be nil because the woman is dealing in perishable products. Once you don't sell, then you lose. You will lose it. So maybe tomato, the perishable is tomato or those things that can easily spoil within a short period. Then if there is an unsatisfied demand on any day, it means a loss of goodwill of 6 naira per kilogram. The other time I told you that goodwill is just like good name. Your ability to always provide products for your customer as and when demand is made is when you are going to have goodwill. But once you cannot do that, you are going to suffer a goodwill which will be in a amount type is going to be quantified in monetary terms. And we are now saying the question that for you not to be able to supply, you lose 6 naira. So let us now solve the problem. The first part of the problem will be that we want to allocate random numbers for both purchase and demand. We want to allocate a number for both purchase and demand. So for the first table, we have number of kilogram, kg, for purchase. Then we have probability. Then we have cumulative probability. And we have allocation of random numbers. So, if you look at the question, we are told that kilograms available for purchase are within the range of 1 to 5. So, for under number of kilograms for purchase, we put 1, 2, 3, 4, 5. So, for us to determine the probability is not good, but it is required. So, we go back to the first table in the question. Look at the number of days. Look at the number of days. Place per each day the number of days over total number of days. Whatever you get is going to give you the probability. When you punch your calculator, whatever it gives you is the probability. Can somebody do that one for us? 35 all over 350. That one will give us 1 over 10. And now 1 over 10 is 0.1. So, is it not?
Yes, sir.
0.1. That one will be 0.10. Is it clear?
Yes, sir.
Then we look at 70. We place 70 over 350. That will give 0.2. And that will give 0.20. The third one is 105 over 350. That's 0.3. That will give 0.30. The next one is the same thing, 0.30. And the last one is 35 with 0.1. When you add everything together, you must get 1.00. So cumulative probability now, as usual, the first one will be 0.10, 0.30, 0.60, 0.90, 1.00. The last cumulative probability must give the total probability. The allocation of random numbers. Allocation of random numbers. Now, if you look at that one can be generated using how many numbers that each probability, each day has as its probability. When you multiply by 100, 0.10 multiplied by 100, it goes 10 numbers for the first day. So as I've told you, 00 is always the first number. So you're going to start from 00 and count 10, including 00. And this one will end at 09. The next one will be 01, 02, 029, sorry.
10.
The first, second one will be 10 to 29. Next is 30. That one is 30 to 59. The next one is another 30, 60 to 89. And the last one is 10,
90 to
which
99.
is 90 to 99. Everything you can't have beyond 99 is always the last one, because we are dealing in numbers, random allocation numbers of 2, 2. Now, we have allocated random numbers for purchase now with this table. So the next thing is that we are going to allocate random numbers for demand. So I will not rub this one up now. Let me just continue. We are going to have number of kilograms demand, number of kg demanded, probability, cum probability, allocation of random numbers. So, as usual, the number of kilograms it's for 5 days. 1, 2, 3, 4, 5. Then the probability, we go back to the number of days, the potential demand for over a same period for 5 days, where there's no seasonal variation or whatever. So we go back to the number of days. The first one is 52 and a half. We place it over 350. What do we get? That one should be around 15, 0.15.
Open it. Let's calculate.
52 and a half all over 350. Please put down 350. So,
Sir, can we pause?
Huh?
Can we pause? It's 10
Zero.
minutes. Yeah, pause this one.